Hello class, this video will be covering some of the concepts that could be on exam 4. So let's get into it. Question 1 is asking us to simplify this expression. So we'll first negative 4 to the power of 3, that will be negative 64. And then x to the power of 8, we have an x in the denominator, so we can cancel out the common factor. So this will be x to the power of 7. Then we'll distribute the 2 to y and z. So we're left with y to the power of 2 and z to the power of 2. Then in the denominator, 5 squared is 25. Then we got canceled out this x, so we're left with y to the power of 8 and z to the power of 8. We can now get rid of the y and z. So negative 64 times x to the power of 7 over 25, then y to the 6th, and then z to the 6th. And that is your answer. Question 2 is asking us to simplify this expression. So we'll start by making the negative 3 positive, and we'll do that by flipping the numerator and denominator. So it'll be 7y to the power of negative 2 over 6x to the power of negative 8, all to the power of 3. We can then make the negative 2 and negative 8 positive by flipping the x and y. So this will be 7x to the power of 8, and then 6y to the power of 2, all to the power of 3. We can then evaluate. So 7 cubed is 343 times x to the power of 24 over 6 cubed, which is 216, times y to the power of 6, and that is your answer. Question 3 is asking us to find the inverse of this function. So we'll start out by swapping the x and y. So we will have x equals then 8y plus 9 over 3y minus 8. We can then cross multiply. So on the left side we'll have x times 3y minus 8 equals 8y plus 9. Then we'll distribute the x, so we'll have 3yx minus 8x equals 8y plus 9. Next, we'll move the 3yx to the right hand side, and we can move this positive 9 to the left hand side. So we'll have negative 8x minus 9 equals 8y minus 3yx. We can then factor out a y from the right hand side. So we'll have negative 8x minus 9 equals y times 8 minus 3x. We can divide both sides by 8 minus 3x. So we'll have negative 8x minus 9 over 8 minus 3x equals y. That is your answer. Question 4 is asking us to solve this equation. So a to the power of u equals a to the power of v, then u equals v. So we'll start out by getting these same bases. A can be represented as 2 to to the power of 3. So we'll put 2 to the power of 3 all to the power of negative x plus 32, which then equals, and 32 can be represented as 2 to the power of 5 to the power of x. We can then simplify this using the properties of exponents. So this will be 2 to the power of negative 3x plus 96 equals then 2 to the power of 5 times x. So this will be 2 to the power of 5x. Since we have the same base, we can set the exponents equal to each other. So this will be negative 3x plus 96 equals 5x. We can move this constant to the right hand side, so minus 96. This will equal negative 3x equals 5x minus 96. We can then subtract 5x from both sides, so 5x minus 5x. So this will be negative 8x equals negative 96. Then we'll divide both sides by negative 8. Negative 8. And we'll be left with x equals 12. And that is your answer. So question 5 is asking us to rewrite this exponential statement as a log. So we have the rule that b to the power of a equals n is the same as log base n equals a. So we have this form right now. So to change it to log, we'll have log base b, which is 4. Our n is 16 equals 2. And that is your answer. Question 6 is having us do the opposite, to convert the log statement to an exponential statement. So we have the rule log base b n equals a, can be b a equals n. So we're in this form right now. So an exponential, we'll have our b will be 6 to the power of a, which is 3, equals 216. And that is your answer. Question 7 is asking us to solve for x. So we'll start by changing this equation to exponential form, which will be 4x plus 7 equals 2 to the power of 4. We will then evaluate 2 to the power of 4 and then take 7. So this will be 4x plus 7 equals 16. Then minus 7 from both sides, which will give us 4x equals 9. Then we can divide both sides by 4. We'll be left with x equals 9 over 4. And that is your answer. Question 8 is asking us to evaluate this expression without using a calculator. So we have the property log base a, then a to the r equals r. And when we compare our expression to this property, we can see that our a's match. So, and our r is 63. And so the answer is 63. Question 9 is asking us to evaluate this expression without using a calculator. And so with the property of logarithms, a to the power of log base a m equals m, we can see that our m is 7, and so the answer will be 7. Question 10 is asking us to rewrite this expression as one logarithm. So we can start by changing it to the log of an exponent. So this will be log base 3 u to the power of 6 plus log base 3 v to the power of 5. We can then change this to the log of a product. So this will be log base 3 of u to the 6 times v to the power of 5. And that is your answer. Question 11 is asking us to solve for x. And so our first step will be rewriting this in exponent form. So this will be x equals 2 to the power of 3. Then we'll evaluate, and x equals 8. And that is your answer. Question 12 is asking us to solve the following logarithmic equation. So we'll start out by rewriting this as the log of a product. So this will be log of x times x minus 15 equals 2. Then we can change this to exponential form. So this will be x times x minus 15 equals 10 to the power 2. Then we can distribute this x and evaluate 10 to the power 2. So this will be x squared minus 15x equals 100. We'll bring the 100 over. So this will be x squared minus 15x minus 100 equals 0. We can then factor this into x plus 5 and x minus 20 equals 0. So this will be x equals negative 5, and this will be x equals 20. Log of x the x has to be greater than 0, so this can't be our answer. So our only answer will be x equals 20.